The Chieftain, Challenger, and Challenger 2. At one point in time, they were considered the most hard-hitting tanks when they were added. The Chieftain Mark III was king of 8.0 up to and past the time stabilizers were added. The punchy L11 gun and the L15A3 APDS made it indisputably a force to be reckoned with. It was the only APDS that could reliably pen the T62 and T54 front plates before the 105mm APDS was reworked. The Chieftain also boasted amazing armor, with the turret ring being virtually impenetrable to its peers save perhaps Heat FS and ATGMs. It made the slog grind through the British tech tree more than worth the effort. I can remember getting the Chieftain all those years ago as my second top tier tank and just having a blast, even if it was lacking in the mobility department. It didn't matter. Once hulled down, the Chieftain just laid down hurt against anything it faced. But when the APDS rounds were reworked and APFSDS rounds started becoming the norm, the Chieftain and the newly added Challenger tank started showing its glaring weakness. Lack of mobility is one thing, but the two-piece ammunition started becoming its biggest drawback. Being placed in locations where it was almost always susceptible to penetration, such as the driver portion of the hull in the Chieftain, and I promise you we will talk about that later, and the Challenger's ready rack beside the breech contains propellants that cause ammo racks when hit by ammunition. In today's video, we'll explore how the L11 works and how War Thunder implements it on the level of the game engine. We'll also attempt to explain why the British stuck with the rifled L11 and L30, only switching to the smoothbore 120mm as early as 2 years ago. The Chieftain tank was a product of a design program for the successor to the Centurion series of medium tanks. It started under the name Medium Gun Tank No. 2. For this design, firepower was given priority over mobility and protection. The requirement of the General Staff set the weight for the new tank at 45 tons. As the United States and the British were already cooperating in armored vehicle development since the Conqueror, the United States proposed that this tank be heavily sloped using the T-140 105mm gun with a 100-inch turret ring. The problem was the T-140 was massive, and the British faced the issue of the Sherman Firefly again if the T-140 was to be used. See, the Sherman Firefly, for those not astute with tank development, could hardly fit the 17-pounder in the Sherman turret. The solution for this was to mount the breech sideways and remove the communication and equipment storage at the rear of the turret and move it to an exterior storage at the rear of the turret to be accessed from the inside through a hole cut through the turret. But that wasn't the end of their problems. The huge gun breech was too cramped, and loaders sometimes burned their eyebrows off because of the proximity of the crew to the gun. Aside from this, the gun cradle was also reduced, making the gun somewhat more unstable compared to other tanks. Anyways, back to the T-140. To get around the loader issue, an autoloader was suggested. However, the mechanism was too complex and bulky that only 40 105mm rounds could be loaded into the tank, as opposed to the 65 105mm rounds on the Centurion tank. Had the Chieftain been fitted with the T-140, it would have a massive cannon that fired HVAP, solid shot, and heat rounds. At this point, a study was launched by Armament and Research Development Establishment in collaboration with Fighting Vehicles Research and Development Establishment to study how to fit the same amount of 120mm rounds as the Centurion's 105mm ammo storage. The first suggestion was to use liquid propellants. The advantages of this design were that it improved muzzle velocity and a separate charge was unnecessary. However, the complex loading system needed could not be investigated due to budgetary reasons, and the idea was scrapped. By this time, the study concept program of the British Army was looking into various emerging technologies at the time. Low-velocity guns that fired missiles and slow projectiles such as the M81E1 gun launcher on the Sheridan, a fixed gun mounted onto a variable suspension platform which eventually became the S-Tank, and oscillating turrets such as the AMX-13's turret. They were also looking into vehicles whose engine was at the front, which, funnily enough, is now commonplace in the modern battlefield with most IFVs and APCs mounting their engine in the front, in air-portable vehicles like the FV4401. We now know it as the contentious with a 20-pounder gun, but it had a twin 120mm recoilless rifle design that was loaded by a revolving magazine that fired HESH exclusively. That design never saw the light of day. The next concept was applying technology that ships all over the world were already using: bag charges. The concept of a bag charge projectile was simple. The projectile was loaded along with a propellant that is usually encased in a combustible case. Though a separate projectile and propellant were not new to the British with the Conqueror, that one used a separate projectile and propellant, but that was the result of the gun being of American design and the propellant was encased in a brass case. The need to eliminate the brass casing was for storage consideration, as spent casings would take up space in the fighting compartment and would be a detriment along with the fumes from the spent casing. The bag charge was in a combustible casing that was completely ignited when firing. Furthermore, testing with two-piece ammunition revealed that it did not diminish from the 6 rounds per minute requirement of the British Army. The US and the British, cooperating closely with each other, unanimously agreed that their joint requirement for a new tank armament should be able to defeat 120mm of armor at a 60-degree angle at 2,000 yards. In April of 1956, the Joint Assessment of the Armament Research and Development Establishment and the Fighting Vehicle Research and Development Establishment put out a recommendation for a 120mm gun with bag-charged ammunition. Aside from these requirements, it was also required for the driver to be reclined when the tank was closed to reduce the height and as a consequence lower the weight. The required weight was to be 47 tons, although the target weight should have been 45 tons to meet the requirements of the General Staff. The design phase finally commenced with Leyland Motors being tapped as the main contractor for the new tank, now designated FV4201. However, as Leyland was also working on the Centurion Mark 7 and Mark 8 that were slated to enter service with the British Army, the FV4201 concept progressed slowly. The initial work was focused on the suspension system, which was supposed to be similar to the Centurion, but reworked for a 45-ton tank. Hydrogas suspension was too complex, and torsion bar suspension gave the tank an unreasonably tall ride height. To study the feasibility of a reclined driver in a gun without an external mantlet, 3 vehicles were produced using existing Centurion parts. They were dubbed the 40-ton Centurion or the FV4202. A brief stop in the design process of the Chieftain came when the US and Britain decided to start developing interchangeable parts in their tanks. However, they disagreed on the armament, and the US chose a smoothbore 90mm gun, which became the T95E1 tank. In case that did not meet expectations, parallel development using an American version of the L7, the T254 was also being made under the name T95E5 and T95E7. The British saw no benefit in a smoothbore gun, and the Americans saw no benefit in the bag charge concept. Nevertheless, both nations still tried to make the FV4201 turret and T95 turret interchangeable for some odd reason. Hello? Post-record Doc here. It seems the Americans did consider the 120mm with bag projectiles under the name XM23. Turns out that they did take the standardization seriously, but in the end, they opted to go for a different MBT. But it is interesting that the Americans did consider the 120mm L11 of the British. Originally, the Chieftain was supposed to incorporate the IS-3 slope-welded plates. However, analysis of recovered IS-2 1944 in the British-occupied section of Berlin revealed that a cast hull front that was sloped was the best idea. It was copied onto the FV4201 design. The turret front was also cast and welded with the roof and rear. In 1957, more requirement changes came in, including the changing of elevation and depression angles from plus 15 and negative 7.5 to 20 and negative 10 respectively. On top of this, a requirement for the compatibility of night vision devices was also made. These changes necessitated a taller turret, which meant a heavier tank. To add insult to injury, additional armor was also requested on the front plate and turret front to increase the resistance to artillery shells, thus adding more weight. And the final nail in the mobility department of the Chieftain's coffin came when later that year, NATO decided that NATO tanks should be running multi-fuel engines. From the Rolls-Royce V8 engine, the FV4201 was now being powered by a German piston engine based on the Junkers Humo, completely redesigning the engine compartment and adding a ton to the weight, now near 50 tons. This new engine design was developed by Leyland Motors as the L60. The Royal Armoured Corps held strong reservations against the L-60 stemming from its poor performance from its aircraft engine origins operating in cold climates of Europe. But the government and their civilian advisors waved them off. And the most painful irony of all this, the funniest thing of all this L-60 fiasco, NATO abandoned the multi-fuel concept in less than a year. The British, now saddled with this new engine, continued the multi-fuel concept with the unsuitable engine. And in an even bigger twist of fate, the L-60 in the end couldn't run multi-fuel anyway. It only ever ran on diesel as engineers determined it would take 8 hours in the field to modify the L-60's feed system for other fuels, which made it really unfeasible in combat conditions. The first prototypes of the FV4201 rolled out in 1959. They were fitted with a low-power 500 horsepower L-60 engine at a weight of 50 tons. A 10 horsepower per ton ratio was deemed too low, about 2/3 less than the general staff requirement. While the original specifications promised 700 powers, this would only be met with the Chieftain Mark V with the L-60 Mark VIII. The development of the Chieftain's drivetrain was heavily protracted due to the failures of the gearbox and the engine. In 1960, only 3 TN12 gearboxes completed more than 500 miles with almost no cross-country tests. That means only 3 gearboxes made 500 miles on paved road. They were not tested on cross-countries where changing gears was very hectic. These problems would have been discovered sooner if attention was not focused on the L-60 engine. Firing trials for the FV4201 began in 1961 with P3 becoming the testbed for the L-11 gun. In this configuration, the commander had a 10x binocular periscope and the gunner had an 8x monocular sight linked to the gun. Ranging was done with 50 cal M85 machine gun, which hampered the 120mm range significantly as it could only range up to 1500 yards. The turret traverse remained electrical traverse despite the slower reaction, as it was safer than hydraulic traverses. The British will be vindicated by this design choice in a few years' time. Trials continued until 1962 with the new night vision equipment, and when that was finished, troop trials began with the FV4201 finally receiving the name Chieftain. One of the biggest crew comfort issues of the Chieftain was that it was not fitted with an internal heater as a weight-saving measure, making winter operation in the tank unbearable even if the Chieftain fared well in snowy terrain. Mud was also an issue with the Chieftain's original ground clearance of 17mm. Substituting the road wheels for the Centurion and a new suspension system fixed this issue, and the ground clearance was raised to 22 meters. The gunner was also overworked from maintaining 3 guns: the 120mm L11, the coaxial 7.62mm L8A1, and the 12.7mm ranging gun L21A1. He was also tasked with manning the radio and serving the crew hot drinks as the boiling vessel was seated behind the main armament. But if you think only the loader got away easy, you'd be wrong. The mechanical rammer for the projectile often failed and was a danger to the loader. The Royal Tank Regiment loaders quickly devised a simple solution: use the combustible charge as a ramming device. Officially, this was not met with approval, but with the lack of a better option, the mechanical rammer was removed, and this became the main method of loading. These issues were slowly worked on for 2 years until the Chieftain was accepted into service in 1963. The L-60's most powerful variant would be the L-60 Mark VIII-A found on the Chieftain Mark V, finally achieving 750 horsepower. In War Thunder, it makes it seem like the designers of the Chieftain and Challenger cared not about ammunition fires and just placed ammo where it could fit. But this could not be further from the truth. A big consideration of the designers of the Chieftain and the Challenger was that ammunition fires was one of the leading causes of fatalities in World War II. Tanks that stored ammunition in the turret were the most likely to be hit by enemy fire, as the turret is the highest part of the tank. The British drew this conclusion from their experiences with the M4A4 Shermans that they were using. The British took this matter rather seriously, and with the Centurion, ammunition was stored below the turret ring to reduce the chance of ignition when hit. With bag charges, stowing ammunition could be done more efficiently and safely. Starting with the Chieftain, all APDS projectiles were stored in the turret walls and outside stowage bins, while HESH projectiles and propellants were stored in special storage bins in the hull that had water jackets that spilled a water glycol mixture onto the ammunition in case of perforation to prevent or at least delay a cook-off of the cordite charge. These were battle-proven during the Iran-Iraq War when Iranian chieftain crews were given precious minutes to evacuate the tank once the stowage bin started fizzing with smoke. Of course, this did not mean that the Chieftain was totally immune to cook-offs. If the mixture could not stop the combustion, the tank would still cook off like any other tank. But this at least redeems the Chieftain from being this boombox that War Thunder presents itself to be. Another interesting thing the British learned from World War II was the turret traverse. The British experience with Shermans taught them that if a hydraulic-powered traverse was hit, it could release pressurized hydraulic gases that caused horrible burns to the crew. As such, the Centurions started using electric traverses which were slower than hydraulic traverses but were safer. America would learn this lesson way further down the line in the Six-Day War when the M60 and M48 losses were attributed to high-pressure hydraulic lines being ruptured and incapacitating the crew. I think the way that Gaijin could handle this is give this tanks very low cook-off chances per round. It would simulate the water jacket's effectiveness per damaged propellant. That way, it would at least need 4 to 5 propellants that are hit to ensure cook-off. Another is to implement ammo type detection down to the single ammo used. That way, if I load 100% APFSDS or APDS, it will only have APDS or APFSDS projectile heads in the turret and hull. As it stands, if you take 30 APDS rounds in the Chieftain, 5 HESH projectiles would be placed to the right of the driver and can be hit to cause ammo racking. That's just the top of my head, but I think to at least give the Chieftain and Challenger a leg up, there are simple ways to get around the engine's limitations. Now we get to the Challenger. Here we're going to answer the question of why the British stuck with the rifled 120mm and did not utilize the German 120mm for standardization. The Challenger MBT was a result of lessons learned from the Arab-Israeli War of 1967, also known as the Six-Day War. The emergence of high-explosive anti-tank ammunition from RPGs and Soviet ATGMs became NATO's concern, and the requirements were for a tank that could withstand hits from these weapons. Heat ammunition is not foreign to the British, as they also manufactured heat rounds for the Chieftain but never used it domestically, only producing it as an export round. Another threat at the time was the Soviets pioneering the use of APFSDS rounds with the T-62 and T-64, increasing the accuracy and range of their guns far beyond what NATO was capable of at the time. These threats and the experiences of Israeli tank crews in the Six-Day War vindicated British tank design but indicted the Germans, as the Leopard 1 shared an ammunition layout and the gun drive as the M60. At the backdrop of all this, the Germans were also engaged in a design project with the British parallel to the MBT-70 with the Americans. The British-German effort, called the Future Main Battle Tank, aimed to replace the Chieftain and the Leopard 1. However, like the MBT-70 program, each nation's demands, such as British insistence on exporting FMBT and the division of work, caused the FMBT program to meet its end. The next step in Challenger's conception was Iran's Order of Chieftains. In December 1974, the Imperial Iranian Army outlined an order of 1,200 Chieftain tanks improved to their standards, which would be known as the Sher Iran or the Lion of Persia. Upon approval, the Ministry of Defense designated the project the FV4030. One of Iran's specifications sought an improvement to the relatively weak and unreliable L60 engine of the Chieftain. Rolls-Royce and David Brown Gear Industries designed the engine and transmission, combining it into a single power pack for easy maintenance. The hull needed to be redesigned as the Chieftain simply could not fit the new power pack. This new design utilized the FV4211 prototype, essentially built around the Chieftain Mark V. While these specifications were being finalized, Iran received Chieftain Mark V over 3P tanks, which met some specifications such as automatic gearbox and mine protection. This was designated the FV4030-1. FV4030-2 would incorporate a new rear hull to accommodate the power pack. 2 prototypes were completed and demonstrated in Iran under the name Sher Iran 1 in 1977. Unfortunately, a little event in 1979 known as the Iranian Revolution occurred, and to say that the contract was cancelled was a bit of an understatement. Fortunately for the British, the Jordanians were observing the Shir Iran development and expressed interest in ordering 274 FV4030-2 models, and it was promptly put into service as the Khalid MBT. These tanks were delivered by 1981. The British focus then was on the successor to the Chieftain tank. With the cancellation of the FMBT project in 1977, the British considered acquiring the Leopard 2 or the XM1 but decided against it as it did not fit the British Army requirements. Consideration was made to purchase the Shear 2 as well. However, this never materialized for the same reasons as the Leopard 2 and the XM1. Because of this, it was decided to create a tank from the ground up. The project, dubbed the MBT-80 as a homage to the ill-fated MBT-70, utilized a conventional turreted design with 4 crew members as opposed to the 3 crew members on the MBT-70. 3 key design areas were studied meticulously, namely firepower, mobility, and protection. For firepower, the choice was between the German 120mm smoothbore, the L-44, and the British 120mm rifled gun, the L-11. The British retained the 120mm rifle gun for the simple reason that it could fire both fin-stabilized and spin-stabilized rounds. With a rifled gun, the tank could fire the APFSDS round and a Heat FS round if necessary, as well as the spin-stabilized HESH round. In terms of mobility, the tank was required to run 27 horsepower per ton for a 55-ton tank, which meant that it needed a 1500 horsepower engine. The designers chose between the Rolls-Royce CV12 TCA diesel engine or the Avco Lycoming, now known as Honeywell, AGT 1500 multi-fuel turbine engine. They would be unable to decide between the two until well after the MBT-80 was proposed. The tank was to be fitted with Chobham armor as stipulated long before the MBT-80 project. With delays in the design process on top of the Soviets producing the T-64B and T-72 at a rate of 2,000 per year, more pressure was mounted on the designers to complete the MBT-80. But when it became evident that the late 80s service entry date for the MBT-80 would not be met, and would instead take later than 1990 for the MBT-80 to see deliveries, the MBT-80 program was finally cancelled with a handful of FV4030-3 Shear 2 tanks being delivered to the British as an interim tank while research work continued to find a suitable replacement. The suitable replacement was to be named Challenger. Whether it was a homage to the A-30 Challenger design of World War II remains to be seen, as some sources claim that the replacement was briefly called a Chevlot before ultimately being called the Challenger. In 1981, prototypes were trialed, and it showed that the TN37 gearbox was deemed unreliable. After further rework and inclusion of more prototypes, an exercise called Exercise Challenger Trophy 2 was conducted in Salisbury Plain where the tanks were tested in a 4-day exercise. The tanks performed well, with tanks reaching 70 kph regularly despite a nominal top speed of 56 kph. The Challenger was accepted into service in 1982 with key provisions such as fixes for the problems with the engine, laser rangefinder, gearbox, and gun sights. The first unit to receive the Challenger was the Royal Hussars that received their tanks in April of 1983. The Challenger utilized the L11A5 gun operating the same 2-piece ammunition as the Chieftain. The Challenger utilized the L15A4 APDS, which is why in War Thunder the Challenger Mark II debuted with this round as its stock round. The L23A1 APFSDS, L31A7 HESH, and L34A2 Smoke. The gun was sighted through the new Thermal Observation and Gunnery Sight or TOGS, which was composed of 2 channels, the Thermal Sighting System and the Gunnery Sighting System. These 2 channels were connected to the Tank Laser Sight No. 10 Mark I with a 1x and 10x magnification. The laser rangefinder was a neodymium YAG laser rangefinder that can operate up to 10,000 meters. Information from this rangefinder was fed to a Marconi computerized sighting system that uses information from the laser rangefinder to provide an accurate lay of the gun for the gunner to aim at. The laser rangefinder can also track moving targets. This, combined with hull-down techniques, ensures a first hit probability on moving targets. In 1987, the intention to retain some 1,200 tanks of mixed Chieftain and Challenger models led to a program known as CHIP and CHARM. CHIP, also known as the Chieftain Challenger Improvement Program, were a series of simultaneous upgrades for both the Chieftain and Challenger's fire control system and turret space. Charm, also known as the Chieftain Challenger armament program, focused on a new 120mm gun, known then as the XL30, and improved depleted uranium ammunition for the 120mm rifled gun. However, the increasing obsolescence of the Chieftain made it very risky to upgrade the tank to serve past the 1990s, with tanks like the T-80U and T-72B entering service. Hence, a cheaper interim upgrade commenced, mounting the steel brew protection package on the Chieftain turret and thermal observation and gunnery sights. The Chieftain Mark 11 was the final model for the British Army, and the Mark 15 would be the final overall Chieftain model, being delivered to Oman. The Chieftain was eventually phased out of service by 1995 thanks to the completion of the Challenger 2. The Challenger 2 was born out of Staff Requirement 4206 by 1987. Following the disastrous performance of the Chieftain dead last in Canadian Army Trophy in 1985, and the Challenger placing the same in Canadian Army Trophy 1987, the investigations of the Challenger's poor performance revealed glaring problems that required immediate attention. Compared to the M1 Abrams, the Challenger acquired targets slower, primarily due to the cramped turret, and the relatively new systems of the Challenger was prone to failure. It was also considered that this new MBT would replace the Challenger in its entirety along with the Chieftain. The original contenders were the M1A1 Abrams and the Leopard 2A4, as they were the only tanks that could fit the requirements set out by Staff Requirement 4206. Vickers Defense System also presented a Challenger 2 Mark II design based on their experiences with the Vickers MBT Mark VII and the Brazilian EET-1 Osorio. The name Challenger 2 Mark II was shortened to Challenger 2, and the Challenger was renamed the Challenger 1. The Leopard 2A4 was rejected due to a critical flaw in its turret armor, and the M1A1 Abrams was selected for procurement by the MOD but was instructed to think again by Prime Minister Margaret Thatcher. In August of 1987, General Dynamics Land Systems and Krauss-Maffei presented their new proposal for the Chieftain replacement, with General Dynamics presenting their M1 Block 2 design, which would eventually become the M1A2, and a Leopard 2A4 with a new wedge turret design to overcome its flaw, which would be known as the Leopard 2A5. GIAT, feeling confident with their new design, also threw the Leclerc into consideration. Although the Leclerc was more of a courtesy, as the Royal Armoured Corps never really entertained the concept of an automatic loader and a 3-man crew. By 1988, Vickers Defense Systems was awarded a £90 million British pound contract to demonstrate the feasibility of their proposal. Under strict guidelines known as the 11 Commandments, they were required to show that their proposal could be developed and produced to the set standard within the proper time frame to make it to the in-service date at a price already offered by Vickers. This was all necessary to even start considering the Challenger 2. As Vickers Defense Systems also accepted the contract for the Charm program as part of the Challenger 2 contract, they were also tasked with developing the XL30 E4 120mm rifled gun and the XL26 APFSDS as part of Charm 1, and the L27A1 with the L16A1 propellant as part of Charm 3. The success of the L26 in the Gulf War, primarily thanks to the record-breaking shot performed during Operation Granby at 4,100 meters, cemented the L30 as the next logical step for the Challengers. It was selected as the main armament for the Challenger 2, and was also initially considered to be fitted onto the existing Challenger 1 tanks. Challenger 2 prototypes were completed in time and within budget by September of 1990 and were due for comparative tests. However, these tests were not held in 1990 due to the invasion of Kuwait by Iraq and the participation of the British in the Gulf War, as all resources were focused on supporting the 7th Armored Brigade in Saudi Arabia as part of Operation Granby. The 4th Armored Brigade arrived at the Gulf in November to form the 1st UK Armored Division with a total of 221 Challenger tanks. These tanks were the Challenger Mark III variant and were subsequently upgraded in the field with extra armor. Due to the efforts of Vickers Defense System volunteer engineers as well as volunteers from Barnes Stroud, David Brown, Perkins, and others, 174 of the 176 tanks committed to the battle were ready at the start of Operation Desert Sabre, the land offensive portion of the British Gulf War campaign. The rest of the 221 were kept in reserve for the remainder of the war, and by the end of the war, Prime Minister John Major cited the Challenger as the overall definitive winner of the land offensive. The thermal observation and gunnery site allowed the Challengers to operate at night against the poor night fighting equipment of Soviet and Chinese tanks, as well as operate in coordination with infantry through GPS guidance. Experience from the Gulf War would also be considered in the competitive trials now held in the spring of 1991. In the 1991 comparative trials, all four tanks, the M1A2, Leopard 2A5, Leclerc, and Challenger Mark II performed up to standard. However, because the Royal Armored Corps did not wish to rely on automatic loaders and a three-man crew, the Leclerc was first to be eliminated, as well as because it was French. The pervasiveness of the German engineering meme also affected the selection process, as a strong cabal of Leopard 2 fanboys within the Defense Procurement Agency maintained the Leopard 2 as the prime choice. Another faction endorsed the M1A2 Abrams, but the Royal Armored Corps also believed the Challenger 2 to have superior survivability to the Leopard 2 and was also placed for consideration. The lack of a unanimous decision from the Defense Procurement Agency meant that the government was left to decide which tank to procure. A strategic defense review in 1991 led to a series of budget cuts in the Ministry of Defense's long-term procurement, and thus led to a significant reduction in the tanks that were to be acquired in the short term. This means a whole fleet replacement of the Chieftain and Challenger was no longer possible. This, coupled with the eventual fall of the Berlin Wall earlier, meant that smoothbore interoperability was no longer an imperative, and replacing the entire fleet with either the M1A2 or Leopard A2 was no longer necessary, on top of the plans to refit Challenger 1 tanks with the L-30 gun. On the 21st of June 1991, the cabinet finally decided to procure the Challenger 2. A week later, a contract between the MOD and Vickers Defense Systems for an initial order of 127 tanks was signed, to be in service by 1993. The first batches of the Challenger 2 were to be fitted with the Charm 1 suite, the L-30 gun, and the L-26 depleted uranium APFSDS round. Further trials continued for reliability and growth until 1994, when the MOD decided that the Challenger 1 was to be put out of service to be replaced by 386 Challenger 2 tanks. The Challenger 2, however, was faced with a troubled start. MOD rules stipulated that the Challenger 2 was not to be deemed in service until all issues were rectified, which could not be done by the in-service date. In 1997, the MOD imposed a new set of trials, called the Product Reliability and Growth Trials, in 4 phases. Phase 1 was completed in November, and the rest were completed in 1998. A fielding team also inspected the tank as it rolled off production lines for quality issues, and they were very meticulous. For the 386 Challenger 2 tanks procured, as much as 22,000 faults were recorded and fixed instantly, as agreed between the fielding team and Vickers Defense Systems. Any remaining issues that made it to the tank regiment were fixed within a day or two of the parts arriving. The last great obstacle in the Challenger 2's acceptance was the in-service reliability demonstration. Between August and December 1998, 12 tanks were tested at Armored Trials and Development Unit in Bovington, with some 5,040 kilometers of land being covered, 2,850 rounds of 120mm ammunition being fired, and some 84,000 7.62mm ammunition were expended. And the verdict? How did the Challenger 2 perform out of all those troubled starts? The Challenger 2 exceeded expectations. The last of the Challenger 2 tanks were delivered in 2002 to the A Squadron of the 1st Royal Tank Regiment, which was interestingly also the first ever unit to take a tank into combat in 1916. Finally, the British Army received a tank that was ready to fight a war as soon as it arrived at the regiment. This would be put to the test not more than a year later when Challenger 2s were deployed in Iraq for the 2003 Iraq War. I would not cover the service of the Challenger 2s in Iraq as extensively as I did the Challenger 1, because the video is already long enough as it is, but I would add that like the Challenger 1 Mark IIIs receiving modifications in the field in the form of ERA, the Challenger 2s also received field upgrades that included cage armor and explosive reactive armor blocks and improved armor on the lower glacis plate. In War Thunder, they are designated as a Challenger 2 without the add-on armor, and 2F with the armor blocks. Another upgrade called the Challenger 2 Theater Entry Standard increases the overall protection of the Challenger 2 by producing composite armor blocks on the lower glacis plate. However, all this armor comes at the expense of the struggling engine, and Challenger 2s are noticeably slower compared to its counterparts in other nations. With the mounting tensions in Central Europe in the past years, the Challenger 2 has undergone a thorough re-examination, and the idea of a 120mm smoothbore gun firing NATO shells in British service finally gained traction. With this, we can finally say that
the One Piece! The One Piece is real!
the Rheinmetall put out a proposal in 2019 arming the Challenger 2 platform with the L-55 smoothbore gun, third-generation commander and gunner thermals, and fire control improvements. In 2021, the 800 million British pound deal was signed. Another modernization attempt for the Challenger is the Challenger 2 test bed, armed with a 130mm Rheinmetall gun and a new turret to fit the gun. In a different direction, BAE Systems also presented a defensive modernization for the Challenger 2 dubbed the Black Knight. Fitting the tank with the Satran Paseo commander sights, Leonardo thermal gunner sights, and laser warning systems and active protection systems, the BAE upgrade was more defensive rather than the offensive upgrades that Rheinmetall demonstrated in their two proposals. To summarize, the concept of a 120mm rifle gun began with the Chieftain drawing from experiences with the Conqueror and the requirement to defeat 120mm of RHA at 60 degrees from 2,000 yards, continuing with the Challenger's vision to maintain use of fin-stabilized and spin-stabilized rounds, and stayed with the Challenger 2 because the XL30, as part of the Chip and Charm program, was built first and was to be the new 120mm gun of the old Challenger 1s until such time that the British Army decided to retire the Challenger 1s after the delivery of Challenger 2s. The Challenger 2 as of today remains to be the main battle tank of the British Army and will be for years to come. Coming down from a line of tanks that are almost 70 years in the making, the Chieftain, Challenger 1, and Challenger 2 have proved themselves to be just as capable as their more popular peers like the Leopard 2 and the M1 Abrams. The L11 and L30 guns and the subsequent two-piece ammunitions were not merely the result of the British stiff upper lip in the face of technology and tank development. It is a carefully crafted and studied consideration that War Thunder and any other game that features this tank as an implement fails to properly convey. Instead portrayed as a slow and lumbering giant boombox, the tank is often considered inferior by players that completely miss the point of the Chieftain, Challenger 1, and Challenger 2. These tanks are merely victims of an unforgivable meta. And now, we close the book on the storied past of these tanks. If you made it this far, again, kudos to you and thanks for watching. If you like this video, please consider subscribing, and for more videos similar to this, I've created a playlist of my videos that cover more historical topics rather than gameplay perspectives about tanks in War Thunder. As we're very close to hitting 2,000 subs, I will be preparing the 2,000 sub video, so this video will be met with a brief intermission of a gameplay-oriented video. This is the Dr. MD, thanks for watching, and Godspeed.